Hi, this is Dr. Goldstein, and I am going to discuss indeterminate limit forms. Specifically, I'm going to talk about some forms that come up when we're dealing with algebraic functions. So algebraic functions are functions that we get with the operations addition, subtraction, multiplication, and division, along with being able to take rational roots, so square roots, cube roots, etc. Now, I've actually already done some videos that deal with some of these. If you want to learn about indeterminate limits of the form 1 over 0, you'll actually want to look at the video that is on infinite limits and indeterminate forms, and I'll put a link to that in the description. So this is the video on infinite limits and indeterminate forms. And I also talked about limits of the form 0 over 0 previously. So this one you'll want to watch the video on the cancellation theorem for limits. So this one's the cancellation theorem. So today, mostly, I am going to talk about limits of the form infinity over infinity, infinity minus infinity, and also a little bit 0 times infinity, but not a ton on that one. So the idea behind indeterminate limit forms is that you can't figure out just from the form what they're equal to. So the idea is that you have to look at the actual quantities involved not just the form, to determine the limit in order to determine the overall behavior. So what we do, a way of describing our general method for these, and again, there's other methods that we'll cover later, especially when you're dealing with transcendental functions. These methods don't really work. But our method for today for algebraic functions for these types of indeterminate forms is to manipulate the expression algebraically to turn it into a non-indeterminate form. So we have a cute little double negative that's happening there. Non-indeterminate means it's a determinate form, meaning you can see what it's equal to. You can determine. Okay, so that's the idea behind these. You want to manipulate it algebraically so that you know what it's equal to. So here is an example, our first example. If we look at the limit as x goes to infinity of minus 3x squared plus 4x plus 11. So this first term here, if I take a large number and I square it, it's going to be very, very large. And then when I multiply that by a negative number, I'm going to get negative infinity. This second term here, again, I have a very large number, but it's multiplied by a positive. So this one's just going to be infinity. And then 11 is just 11. This is a finite number. So overall, and then you can lump that in with that infinity. So overall, these two terms go to infinity. So overall, our limit has the form negative infinity plus infinity. In other words, infinity minus infinity. And with this form, we do not know which one of these wins. We don't know. Is the first infinity bigger? Is the second infinity bigger? Does it go to 0? Do they cancel? We don't know. So a method that I like to use for this form, infinity minus infinity, is you force factor. And what on earth do I mean by force factor? There isn't necessarily a particularly good way to factor this expression so that it factors nicely, but what I can do is I can factor out the highest power of x anyways, and it's just going to look kind of messy. So if I look at the power of x that I have here, I have an x squared, this term has an x to the 1, this term has an x to the 0, so the highest power of x that I have is this x squared. So I factor that out, I take out an x squared, and I'm left with, in the first term it comes out nicely, I just have a minus 3. But in the second term I take out one x, I have no x's, and then I take out another x, and I have minus 1 x's. In the last term I have no x's, so I take 2 out, and I have minus 2 x's. So I don't normally write it like this, but it's a good way of showing you what exactly is going on here. Overall, when I force factor, I take out 2 x's. In the first term, it's fine. In the second term, negative powers means that that part goes in the denominator, and then in the third term, I have 2 x's that go in the denominator. So when I force factor, I want to take out the highest power of x. So we take out the highest power of x. And in my experience, this usually turns my limit into something that is not indeterminate. So now if I evaluate what the different parts of this limit do, this x squared is still going to go to infinity. The minus 3 is just minus 3. But now 4 over x, that's 4 over a really big number, that's 0. Same with this term here. This is 11 over a really big number, that's 0. So this limit now has the form infinity times negative 3 plus 0 plus 0. In other words, it's infinity times a negative number, and so it's just negative infinity. So this limit is equal to negative infinity. And so my overall answer of what wins? Well, the highest power of x wins. That minus 3 makes it negative, and then the highest power of x takes over. But we don't see that until we force factor this, and we turn it into an expression where I can say, oh yeah, I know that. That's a big number times a negative number. That's a negative really big number. Okay, so this is a method that works really, really well for infinity minus infinity. Let's look at another limit. So here I have the limit as x goes to infinity of x squared minus 1 divided by x squared minus 4x. So on the top of this, I have infinity squared minus 1. That just goes off to infinity. And on the bottom here, I have infinity squared minus 4 times infinity. So that goes off to infinity minus infinity. So that is an indeterminate form. So let's look at the bottom part of this separately for a minute to figure out what this does. So if we take the limit as x goes to infinity of x squared minus 4x, again, this has form infinity minus infinity, so I'm going to use this method that we just learned of force factoring. My highest power is x squared, so I'll factor that out, and I have a 1 minus 4 over x. And now if I look at this limit, it has the form infinity times 1 minus 0. So that's infinity times 1, and that's just infinity. Cool. So I've sorted the bottom part of this, but overall I know that this limit has form infinity over infinity. My original limit has form infinity over infinity. And I don't know which of these infinities is bigger and which of them is smaller. So there's actually 2 different methods that you can use when you have a fraction. I'm going to use the same force factoring idea. And because I have a fraction, I'm going to end up being able to cancel powers of x. So let's look at this method, and then I'll show you a different one. So I've actually already force factored the bottom. I know that I get an x squared 1 minus 4 over x. And then on the top, when I take out that x squared, in the first term it comes out nicely, and then again in the second term I'm taking out 2 x's where I didn't have any. So I have 1 over x squared. When I cancel these x squareds, I'm left with the limit as x goes to infinity of 1 minus 1 over x squared over 1 minus 4 over x. And now each of these terms I can just evaluate. On the top, 1 goes to 1. 1 over x squared goes to 0. And on the bottom, I end up with 1 over 0. And so this limit just ends up being 1. And that's my final answer. So in this case, infinity over infinity is just equal to 1. Now, on the other hand, another method, because some people don't like force factoring, and I don't blame you. Another method is to divide out by the highest power of x. And when I say divide out, what I mean is to divide the top and the bottom. And why is this legal? Because really, it amounts to just multiplying by 1. So let me write this down for you, and you'll see what I mean. So I have my x squared minus 1 over x squared minus 4x. The highest power of x is x squared. So I'm going to divide everything on the top by x squared, in multiplying by 1 over x squared. That's what I end up doing. And I'm also going to do the same thing to the bottom. So here, I'm multiplying by 1 is what I'm really doing. So it doesn't change my original expression. Now when I do that, I distribute this everywhere. So I have x squared times 1 over x squared minus 1 times 1 over x squared. On the bottom, I have x squared times 1 over x squared minus 4x times 1 over x squared. And now when I simplify that, I get 1 minus 1 over x squared over 1 minus 4 over x squared. So it's actually the exact same thing that I got by force factoring. I just got at it a different way. And again, after I get to this point, I can just evaluate all the different parts. I have 1 minus 0 over 1 minus 0, which is just 1. So this is two different methods of dealing with the form infinity over infinity. All right, let's see another problem. So here we have the limit as x goes to infinity of x to the 4th over 1 minus 2x minus x cubed. Again, we'll evaluate what type of limit this is. The top goes to infinity, and on the bottom I have this 1 minus infinity minus infinity. So the bottom has the form infinity over negative infinity. So this is, again, infinity over infinity. I'll start by this force factor and cancel method. Just so you can see it again. So I don't have to do anything on the top. It's just the one term. And on the bottom, the highest power is x cubed, so I'll take that out. And I get 1 over x cubed minus 2 over x squared minus 1. I cancel. I'm left with an x on the top. And so what I have is x over 1 over x cubed minus 2 over x squared minus 1. And now I can just evaluate each of the parts of this. On the top, I'm going to get infinity, and on the bottom I'm going to get 0 minus 0 minus 1. So this has form infinity over minus 1. It's not indeterminate anymore. If I take a very large number and I divide it by minus 1, it's going to be a very large negative number. And so overall my limit is equal to negative infinity. Now on the other hand, I can divide out by the highest power of x. And I'm actually going to show you what happens if you don't do this correctly, because I need to add to this. So the highest power of x overall is x to the 4th. So I have x to the 4th over 1 minus 2x minus x cubed. And again, the idea is I'm just dividing everything by x to the 4th. And really what this looks like is I multiply the top and the bottom by 1 over x to the 4th. I have to distribute it everywhere. But really in my head, I'm just taking every single term and I'm dividing it by x to the 4th. So on the top I get 1. On the bottom I get 1 over x to the 4th minus 2 over x cubed minus 1 over x. And now the problem with doing this, I mean, I haven't done anything illegal. This is still true. But now when I do this, the top goes to 1. And on the bottom, all 3 of these terms go to 0. So this now has form 1 over 0. This is indeterminate, and I'm sad because I don't know what this limit goes to. So I do want to divide out by the highest power of x, but I want to divide out by the highest power of x that appears in the denominator. So I don't just want to divide out by the highest power of x overall. I want to divide out by the highest power of x that appears in the denominator. And this is what this looks like. So the highest power of x in the denominator is x cubed. So I divide the numerator by x cubed. Oops, that's a squared. I said cubed. And I divide everything in the denominator by x cubed. So now I get x on the top, and on the bottom I get 1 over x cubed minus 2 over x squared minus 1. And again, notice this is the exact same thing as we had before in the other method. So these two methods really are the same thing as long as you apply them correctly. And now I can just evaluate this. This has the form, the top goes to infinity, the bottom goes to minus 1. And so overall my limit is equal to negative infinity, which is the same as what I got before. All right, let's recap a little bit. Notice both this problem and the last problem, my limits had the form infinity over infinity. In this problem, infinity over infinity ended up going off to negative infinity. So I got a big, 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 big number. The last problem, this was still the form infinity over infinity, but this limit was finite. It actually was equal to 0. And it's entirely possible that you'll have a limit of the form infinity over infinity, and it goes to 0 even. I mean, it can be really small. So this is what we mean when we say that this limit form is indeterminate. Infinity over infinity is indeterminate. It depends on the details of the problem. And so you have to do this kind of algebraic manipulation to figure out what the limit is equal to. So I'm going to end with one more problem. We've done infinity minus infinity, and we've done infinity over infinity. Now we have to do 0 times infinity. So when we evaluate this limit, remember negative powers are 1 over. So x to the minus 1/2 is 1 over the square root of x, so this approaches 0. This approaches 0. This is not very good mathematical notation. I wouldn't blame you if you have no idea what I'm talking about. This part of the limit, I have 1 over the square root of infinity. That part of the limit goes to 0. And then this part of my limit, infinity squared plus 1, that's going to go to infinity. So overall, this limit has the form 0 times infinity. And I don't know what this is equal to. On the one hand, if I take anything and multiply it by 0, I should get 0. But on the other hand, if I have something that's infinitely large, if I have infinity and I multiply it by something, I should get an infinitely large number. So which wins? Does the 0 win? Does the infinity win? So this problem, it's actually kind of silly, I think, because this is a really silly way of writing down this function. I can just distribute. I can distribute this x to the minus 1/2. So I have x to the minus 1/2 times x squared plus x to the minus 1/2 times 1. And so when I simplify, simplifying is an algebraic manipulation. When I add exponents, I get x to the 3/2 plus x to the minus 1/2. And if you think about what that actually means, you're like, oh, fractional exponents, no. Remember, don't freak out, fractional exponents. in the first term, x is being cubed, and then I'm taking the square root. And then in the second term, the negative means 1 over, and to the 1/2 means the square root of x. So when I look at this first term, I have the square root of infinity cubed, which is infinity. The square root of a very, very, very big number is still a big number. And then 1 over the square root of infinity, this is going to be 1 over infinity, which is 0. So this limit now has the form infinity minus 0, which is just infinity. So it's no longer indeterminate. It started out as indeterminate. We do some simple algebra, and it's no longer indeterminate. So here's a couple of different algebraic manipulations that you can do based on each of these forms. So one thing to note is later I'll be discussing some other methods. There's some other really nice standard methods for 0 over 0, infinity over infinity, and also 0 times infinity. There's better ways of dealing with these. Sometimes. These are nice methods. But really, for infinity minus infinity, really your best method is to factor. So in later videos, I'll be discussing more methods for these other indeterminate forms, but really when you're dealing with infinity minus infinity, your first course of action is to factor that. So please bear in mind when you're dealing with indeterminate limits, they are very, very tricky. But I hope that this video helps clear up a few of these particular indeterminate types.